Hello everyone, welcome to the project demo of EV charging station utilization powered by Azure AI. The first step for this project is to have an Azure account and to select a subscription. Inside the subscription, we need to create something called resource group, which are logical units for storing resources. Now, the resource group that I have created for this project is Rajoshi Major Project RG, and we can click on this resource group and add resources inside it. So inside this resource group, we will be clicking on the create button for adding the different resources. As you can see, all the resources required for this project have been already added into the resource group. The next step is to create the service principal. For that, we will be typing Microsoft Entra ID in the global search, and then a page like this will be opening where under the manage tab inside the app registrations, we need to click on new registration. We need to follow the steps and we will be able to create our service principal, which is Rajoshi SP in my case. The service principal contains client ID, object ID, tenant ID, and client secret. Now, this client secret has to be stored in the key vault. For doing that, we will be moving on to our key vault instance and search for secrets. Under the secret tab, we will be having this generate or import option from where we can get our secret value and copy it here and store it. The next step is to store the data in the Azure Blob, as we had discussed in the architectural diagram. For that, we will be going to the storage account, which is raw data EV charging, and under containers, we will be clicking on the raw EV container. So using this plus container button, we have added this container. And once we are inside the container, we have the option of uploading. And this is the raw EV data file. The next step in the architecture was to create data factory pipeline using Azure Data Factory, and this is the data ingestion step. For doing that, we can go back to the resource group. Inside the resource group, we have our data factory instance. So once we click on it, we will get an option for launching the studio. So once we launch the studio, a page like this will be opening. This is the instance Rajoshi Data Factory. And under the Manage tab, we need to go to Connections and Link Services. So whatever services we are going to use in this Data Factory, we have to create a link service for it, which are the Blob storage, Databricks, and Data Lake in our case. Link service is a connection between the Data Factory and the Azure. The next step is to go to the Authors tab and create a pipeline. Inside the pipeline, we will be able to drag activities from this activities panel and place it in this section. So our pipeline is having two activities. One is the copy data activity and another is the notebook activity. The copy data activity is having a source, which is the blob path. If we look over here, we will be able to see that this is the raw EV data file that we had seen. And the next is the sync path, which is the bronze container for EV data lake. So if we check the sync of it, it is the output data set, which is having the path of the bronze container. Now the output data set has been stored in the Parquet format for faster calculations. All right, after that, the next step in this pipeline is to have a notebook activity. For that, first we need to create a notebook. For that, we will be going to our Azure Databricks instance and launching the workspace. Once we do so, a page like this will be opening, where under the workspace tab inside the shared folder, we can create our notebook. So this is the notebook that I will be using, that I have created, which is Data Transform 1. And for running the Databricks notebooks, we require something called compute cluster, and it should be running. Now, since I am not using the cluster now, that is why it is in the terminated state. But whenever we are running the notebooks, then or the activity from the pipeline, then this cluster should be in the running state. So this is the cluster that I have used, standard D4SV3 with 16 GB memory and 4 cores. All right, the first step in this notebook is to create a secret scope. The secret scope will be a connection between the Databricks and the Azure. So this secret scope will be having a key, which is securely stored inside the key vault. So again, under the secrets tab, we will be able to see this is the secret scope secret, which is EVKV secret. And this has been referenced here for authentication. Once the authentication is completed, the next step is to provide the config files and mount the bronze and the silver containers. So over here, I'm mounting the bronze container. And next part, I'm mounting the silver container. Now, something to note here is that first I have unmounted the silver and bronze containers and then I have mounted them. This is because I have run this pipeline multiple times. So, if I do not unmount it, it will be throwing an error. This process can be overcome by using the if statement. Once the mounting is completed, we will be reading the data from the bronze container. This is how the raw data looks like. So we can see there is a column with no proper headers, and under that there is another column starting with a null value. And if we check here, we have the vehicle types and then the total, that is the grand total vehicles, and then total charging station. Inside the total charging station also there are some rows that are having null value. Now we need to perform data transformation on this. For that, first we will be reading the bronze container, and on that we will be performing transformation. First, to remove the column that is having no proper header, and then the column that is starting with a null value, and finally the rows under the total charging station that are having null values. So once this cleanup is done, we are going to add two more columns, which is the utilization and the utilization category. Utilization is the column which is calculated using grand total by total charging station, and utilization category has been calculated using the quantiles method, and it has been categorized into underutilized, optimally utilized, and overutilized. Once this is done, we will be writing this clean form of data inside the silver container in the Parquet format. So we will have a look at these transformations. So as we can see, the first column having prop 0, prop 1, first row having prop 0, prop 1 has been removed, and the column having starting with a null value has been named as none as of now. And in the next set of transformation, we have removed this none column and also the rows which were having null values under total charging station. And we have added two more columns, which is the utilization and the utilization category. Once all of this is done, we will be going back to our pipeline, adding the notebook activity, and in the Azure Databricks, we will be providing the link service connection. Once this is done, we will connect these two activities and click on the debug option. Once the pipeline is run successfully, we can check the output in the data lake. So inside the data lake under the bronze container, we are supposed to have a copy of the raw data. Let's have a look at that. And this will be stored in the Parquet format. So this is the raw data in the Parquet format. And if we go back and check the silver container, we will be able to see the clean data set inside this file. Now that we have completed till this part, we will be moving on to the AutoML job. For that, we need to log into our machine learning workspace. So this is the workspace that I have created, Rajoshi EVML workspace. Now, in order to run an AutoML job, we need to have a compute instance or a cluster. And I have created a cluster with the name of EV AutoML compute. We can click on the new button and create different clusters. Once this is done, we can go to the automated ML tab and click on new automated ML job. So inside this, we will be having to complete all these steps. Some of them, let's see. So first we have to give the job name, experiment, etc. I think we need to type a comment here. Once this is done, it will be asking for the task type. So on what the model needs to be trained. For our case, it is regression. And we can create a data set here, or we can reference here the data set. So we are referencing here the data set, and the data set can also be created using this data tab under the asset section. So once this is done, we have to put the task settings like how many times you want the job to be ran, what is the threshold that we want, what is the primary metric on which we want our calculations to be done. Do we want to split our data that we are having, the clean data that we are having, into training and validation sets or not? And select the compute cluster, review all of this, and then click on the create button. Once we do this, we will see our job is created, and this is how it will look like after completion. So as you can see, inside this job, there are multiple sub jobs that has been run, and the AutoML has chosen the best model here. So if we look into this job, we will be able to see the best model predicted by the Azure AutoML for our requirements. We can also see what are the matrices that has been used, like the mean absolute error, percentage error, normalized root mean square error, etc. And to know more about this model, we can click on the model tab and look at the algorithm that has been used, which is max ABS scalar light GBM. We can check the hyperparameters. What is the primary metric that has been used? What are the list of all the other metrics that the AutoML has used for selecting this as the best model? All of this can be done. We can even deploy this model to a real-time endpoint or batch endpoint or web service, depending on our requirement. Under the outputs and logs section, we will be getting the explanations, outputs, and other Python files that we can customize further. We can even download this model and also check the code that has been generated, which we can customize further based on our requirements. So this is how we are going to train our model and find out the best model using the Azure AutoML. The last part of this project is to perform data visualization using Power BI. For that, we will be logging into our Power BI desktop account. And inside that, we have to go to the get data option. Inside the get data, there is an option called more. Click on it. Inside this, we can search using data lake. Click on this, click on connect. It will take some time to load. We can add the data lake URL that we have and click on OK. So if we have already established a connection and the method that has been used, like SAS token in my case, has not expired, then it will not ask you to re-authenticate. But if you're doing it for the first time, it will be asking you to re-authenticate. And the method that we have used is the SAS token. So SAS token is shared access signature that will help to securely load the data into Power BI from Azure. So once we click on OK and update our SAS token details, we will be able to create visualizations. So this is the visualization that we have created: state name versus sum of utilization and utilization category versus sum of utilization. And this is a dynamic report because we can customize it according to the years. So we can see that the overutilized rates of all the states that has taken place, or maybe we can switch to something different. How many states have overutilized, underutilized, and optimally utilized during 2022. We can even check for a particular state. Like if we just click on Bihar for 2022, we will be able to see how much overutilization has taken place. This is first report. Let's move on to the second report. In the second report, we are plotting a graph for total charging station with respect to sum of utilization. Over here, the state name and the year is dynamic. So we can select any state, maybe Haryana, and we can see how the graph is altering. We can even select an year. Let's select 2020 or 2022, and it will be giving us the desired results. So this is how we can create powerful visualizations using the Power BI. This is all about the project.